Beneath our feet, the Earth is never truly still. Hidden across the globe are vast cracks and fractures, giant scars that split open the land in ways almost beyond imagination. Some appear suddenly, swallowing everything in their path, while others grow slowly over centuries, stretching wider with each passing year. They're so immense that satellites and astronauts can spot them from space, yet most of us never realize they exist. What secrets do these colossal rifts hold about the forces shaping our planet and the dangers that still lie ahead? Stay with us as we uncover some of the most mysterious earth cracks ever caught from above. But before we move forward, make sure to like this video, subscribe, and hit the bell icon so you never miss our latest explorations. Thingvellir, where continents drift apart. In southwestern Iceland lies Thingvellir National Park, home to one of the most visible tectonic rifts on Earth, the boundary where the North American and Eurasian plates slowly drift apart. Here, the planet is literally being stretched as the plates separate by about 2.5 centimeters each year. This is part of the Mid-Atlantic Ridge, a massive underwater mountain chain that rises above sea level in Iceland, making it one of the few places on the planet where visitors can see a plate boundary with their own eyes. The Rift Valley extends for kilometers, marked by jagged cliffs, wide fissures, and dramatic scars left by thousands of years of tectonic movement. The most prominent crack runs more than 7.5 kilometers and plunges nearly 64 meters deep. Other fissures form a striking network across the volcanic plain, so sharp they can even be traced from space. Earthquakes, land subsidence, and uplift continue to reshape the area, while lava fields and water-filled cracks reveal Iceland's fiery volcanic past. Despite its restless geology, Thingvellir has been a center of human history for over a millennium. In 930 CE, the Alþingi, the world's first parliament, was founded here. Today, visitors can walk between continents or even dive into Silfra, a crystal-clear fissure with some of the purest water on Earth. Thingvellir remains one of the most awe-inspiring windows into Earth's living geology. The Dabbahu Fissure, Africa splitting apart. In 2005, a dramatic geological event shook Ethiopia's remote Afar region, an event so immense it was visible from space. This was the birth of the Dabbahu Fissure, a rupture stretching more than 60 kilometers and gaping several meters wide in just a matter of days. Its cause was extraordinary. Underground magma forced its way upward, splitting the Earth's crust with remarkable speed. The Afar Depression, where this occurred, is among the most geologically unstable places on the planet. It lies at the junction of three tectonic plates, the African, Arabian, and Somali plates, making it a hotspot for earthquakes and volcanic upheavals. The fissure's formation was triggered by a swarm of over 160 quakes, climaxing in an eruption from the Dabbahu volcano. But instead of blasting upward in a towering eruption, the magma traveled sideways underground, prying the crust apart like a wedge. For scientists, this was a rare glimpse into the early stages of continental breakup, a process that usually unfolds over millions of years. Over time, continued rifting in this region could ultimately split the Horn of Africa from the mainland, creating an entirely new ocean basin. From above, the Dabbahu Fissure is a stark, jagged scar etched into Ethiopia's arid landscape, intersecting with older cracks that reveal a land in constant motion. The Afar Depression remains a natural laboratory, offering living proof of the immense tectonic forces shaping continents and oceans. The earth cracks of Badwater Basin, Death Valley. Badwater Basin in Death Valley, California, is a place of extremes. At 282 feet, 86 meters below sea level, it marks the lowest point in North America. But beyond its record-setting depth, the basin is etched with a striking network of fractures and salt polygons, patterns so distinct they can be spotted from space. Unlike the colossal rift valleys of Africa or Iceland, the cracks here are the product of a different recipe: relentless desert heat, ancient salt deposits, and the slow stretching of the Earth's crust. Death Valley lies within the Basin and Range province, where millions of years of crustal extension pulled the land apart, leaving behind steep mountain ranges and deep valleys. Faulting carved the valley itself, while long-vanished lakes left behind the salt flats that dominate its floor today. As temperatures soar, the salt crust expands and contracts, fracturing into geometric shapes that resemble white scars across the desert floor. Most polygons are just a few meters wide, but larger fissures run for great distances, linking with fault lines along the valley's edges. From orbit, these gleaming patterns appear almost artificial, like an alien grid etched into the desert. Beneath the surface, active fault systems such as the Furnace Creek and Southern Death Valley faults continue to shift the landscape, though at a slower pace than Africa's rifts. The result is a terrain in constant subtle motion, where climate and geology conspire to create designs both fragile and enduring. The Jidatan Earth Fissure, Tibetan Plateau. High on the Qinghai Tibet Plateau lies the Jidatan Earth Fissure, one of China's most dramatic examples of active surface cracking. It sits within the Kunlun Fault Zone, a colossal boundary where the Indian and Eurasian plates collide. The immense tectonic pressure here, amplified by the plateau's brutal freeze-thaw cycles, relentlessly tears at the Earth's surface. The region came into global focus after the 2001 Kunlun earthquake, a magnitude 7.8 event that ripped the ground open for more than 400 kilometers. Some fissures reached up to 2 meters wide and stretched across villages, roads, and rivers, reshaping the landscape in a matter of minutes. The scars remain visible today, etched into the high plateau like tectonic handwriting. Scientists now monitor Jidatan with satellites, radar, and GPS networks, mapping how the cracks expand and shift over time. These studies not only reveal how stress is distributed across the Tibetan Plateau, but also highlight the interplay between climate and geology, where seasonal freezing and thawing act like wedges, deepening fractures along fault lines. From above, the fissures stand out sharply, especially after rain or snow darkens their edges against the pale surface. Though the area is remote and sparsely populated, its restless ground offers an extraordinary natural laboratory. Here, Earth's crust is being reshaped in real time, its scars so vast they can be traced from space. The San Andreas Fault, California's giant scar. The San Andreas Fault is one of Earth's most iconic geological features, a colossal crack stretching some 1,200 kilometers, 750 miles, through the heart of California. It marks the boundary between the Pacific Plate and the North American Plate, where the two grind past one another in a slow but relentless horizontal dance. Moving at about 30 to 50 millimeters per year, this motion has carved a massive linear scar across the state, visible both at ground level and from orbiting satellites. Running from the Gulf of California in the south to Cape Mendocino in the north, the fault slices through deserts, valleys, farmland, and rugged mountains. In the Carrizo Plain National Monument, the fault is especially striking, a razor-straight line etched through rolling grasslands, where streams, ridges, and ponds are visibly displaced by the sideways motion of the plates. From above, the San Andreas appears as a stark groove cutting across the landscape, emphasized by sharp contrasts in terrain and vegetation on either side. It is also a source of some of California's most destructive earthquakes, including the infamous 1906 San Francisco quake, which ruptured nearly 470 kilometers, 296 miles, of the fault and shifted the land by up to 6 meters. Even during its quieter phases, the fault never rests. GPS and satellite radar reveal creeping shifts, subtle uplifts, and gradual changes that accumulate over time. Geologists divide the fault into 3 main segments, the northern, central, and southern, with the southern portion near the Salton Sea considered overdue for a major rupture. From space, the San Andreas Fault is a scar of continental scale, a reminder of the immense tectonic forces shaping California's past, present, and future. The North Anatolian Fault, Turkey. Stretching across northern Turkey, the North Anatolian Fault is among the most dangerous cracks on Earth. Comparable in scale and power to California's San Andreas Fault, it runs nearly 1,500 kilometers, 930 miles, from the Aegean Sea in the west to the rugged mountains near Armenia in the east. This fault marks the restless boundary between the Anatolian and Eurasian plates. It is a right lateral strike-slip fault, meaning the land on either side slides horizontally in opposite directions. Over the past century, this relentless movement has unleashed a devastating chain of earthquakes, rupturing one segment after another in a domino-like sequence. The 1999 Izmit earthquake remains the most infamous. Lasting just 37 seconds, it tore open a 150-kilometer, 93-mile rupture and shifted the land by more than 5 meters. From above, the scar cuts through farmland, rivers, and even the coastline of the Sea of Marmara, a wound still visible in satellite imagery. Along its path, the fault has shaped valleys, offset ridges, sag ponds, and long, narrow lakes such as Lake Sapanka, which lies perfectly aligned with the fault line. These striking features make it clearly visible from space, even in quiet periods. The most alarming detail? The section nearest Istanbul hasn't broken in over a century. GPS and satellite data reveal immense strain building, making it one of the most likely places on Earth for a catastrophic future quake. The East African Rift System, Ethiopia to Mozambique. The East African Rift System, or EARS, is one of Earth's most dramatic geological features, a colossal scar stretching more than 3,000 kilometers from Ethiopia's Afar Triangle through Kenya, Tanzania, and Malawi before reaching central Mozambique. This isn't a single fracture, but an immense network of rifts, valleys, and faults marking where the African plate is slowly tearing into two pieces, the Nubian plate to the west and the Somali plate to the east. Scientists believe that millions of years from now, this process could create a brand new ocean basin, cutting eastern Africa away from the rest of the continent. Nowhere is the rift more striking than Ethiopia's Afar region. Here, immense depressions, jagged fault blocks, and frequent volcanic activity continually reshape the surface. In 2005, a massive fissure suddenly opened, stretching over 60 kilometers, an instant reminder that the earth beneath is restless. Further south in Kenya and Tanzania, the rift transforms into dramatic valleys framed by towering escarpments. Some of these valleys cradle vast lakes like Lake Turkana, sitting in a sunken crustal block formed by the rift's pull. From space, the East African Rift is unmistakable. Dark valleys, crater lakes, volcanic cones, and sharp scarps carve a jagged line across the continent. Satellites and GPS show the land is still stretching today, evidence that Africa is, quite literally, splitting apart before our eyes. The Denali Fault, Alaska. The Denali Fault is one of North America's most striking geological features, slicing for more than 1,200 kilometers, 750 miles, across Alaska's wild interior. Part of a vast network of strike-slip faults, it absorbs the grinding force between the Pacific and North American plates. The world took notice in 2002 when the fault unleashed a magnitude 7.9 earthquake, one of the most powerful in US history. The quake ripped open nearly 340 kilometers of ground, shifting the landscape sideways by as much as 9 meters. Forests, ridges, rivers, and even dirt roads were snapped into offset patterns, scars that remain visible to this day. One of the greatest concerns was the Trans-Alaska Pipeline, which crosses the fault. Fortunately, engineers had designed it with flexibility, allowing it to bend with the shifting earth. Against all odds, the pipeline survived with only minor damage, a remarkable success in seismic planning. Like California's San Andreas Fault, the Denali is a right lateral strike-slip system. But what makes it unique is its setting: remote mountains, tundra, and glacier fields, where its jagged trace cuts starkly across the Alaska Range and remains visible even from space. Today, the Denali Fault is far from silent. Monitored by GPS, seismometers, and satellite radar, it continues to shift subtly. Quiet signals of immense strain building below. This fault is more than a crack in the ground. It is a reminder of Alaska's raw, untamed power, and one of Earth's clearest earthquake scars carved into stone and ice. The Western Ghats Escarpment Fault, India's ancient rift edge. Running for more than 1,600 kilometers along India's western edge, the Western Ghats are often admired as lush green mountains. Yet behind their beauty lies something far older, a colossal fossilized tectonic crack carved into the Earth's crust. This escarpment marks the rift boundary of the Indian plate, formed some 100 to 130 million years ago when the Gondwana supercontinent broke apart. As India drifted north toward its collision with Eurasia, its crust split and tilted downward into what is now the Arabian Sea. The result was a steep continental margin fault, similar in origin to Africa's Great Rift Valley, except here the movement has long since stopped. The Ghats rise sharply, in places climbing 1,200 meters within just a few kilometers, separating the coastal plains of Konkan and Malabar from the elevated Deccan Plateau. From orbit, this ancient scar is strikingly clear, a dark wall of uplifted land casting shadows across rivers, valleys and forests, especially dramatic near the Nilgiri Hills. Though geologically quiet, satellite data reveals subtle flexing and slow uplift, driven by erosion and isostatic rebound. Far from a static relic, the Western Ghats are a living reminder of continental breakup, an ancient scar still shaping the Indian landscape today. The Kekerengu Fault, New Zealand. Along the northeastern coast of New Zealand's South Island lies the Kekerengu Fault, thrust into global attention after the devastating Kaikoura earthquake of 2016. During this event, the Earth ruptured with extraordinary violence, carving one of the clearest fault lines ever seen from space. In some areas, the land shifted sideways by more than 10 meters, while the rupture stretched over 30 kilometers across farmland, hills, and roads. Within hours, satellites like Sentinel-2 and Planet Labs captured the fresh scar, a bold brown line slicing diagonally across New Zealand's lush green landscape, as if the Earth had been cut open with a blade. The Kaikoura quake itself was remarkable, involving more than 20 faults rupturing in sequence. Yet the Kekerengu Fault stood out. Aerial photographs revealed fences, highways, and even entire hillsides snapped and offset, with one side of the land abruptly displaced from the other. The contrast of raw soil against surrounding vegetation made the rupture eerily vivid. Part of the Marlborough Fault system, the Kekerengu remains active, absorbing the relentless collision between the Pacific and Australian plates. Today, geologists monitor it with satellites, radar, and LiDAR, regarding it as one of the world's most striking and textbook examples of a living strike-slip fault. Wadi Araba Fault, Jordan. Cutting across the deserts of southern Jordan, the Wadi Araba Fault is one of the most striking segments of the Dead Sea Transform Fault system. This immense tectonic crack marks the restless boundary between the Arabian and African plates, and over millions of years it has carved a scar so distinct that it can be traced even from space. Running nearly 160 kilometers from the Dead Sea to the Gulf of Aqaba, the fault is astonishingly straight. In satellite imagery, it appears like a ruler-drawn incision through the barren landscape, a shadowed valley slicing across highlands and plains. From orbit, it is one of the clearest demonstrations of how continents slowly grind past one another. But the Wadi Araba is more than a visual marvel. It is a fault with a violent past. In 1995, a magnitude 7.3 earthquake struck along the Gulf of Aqaba, deforming the land and leaving offsets still visible today. Paleoseismic studies reveal that similar massive quakes have shaken this desert for millennia, each leaving behind fault scarps, displaced streams, and warped terrain. Near the town of Garandal, the fault bends sharply, creating dramatic elevation changes and shadows that accentuate its form. Here, under harsh desert light, the Earth's slow-motion fracture becomes almost unnervingly clear. Shillong Plateau Fracture Zone, Meghalaya, India. In the far northeast of India rises the Shillong Plateau, a vast block of land lifted high above the surrounding plains. Resting at the collision zone between the Indian and Eurasian plates, it is one of South Asia's most seismically restless regions, bound by powerful faults that continue to shape its dramatic landscape. Among its most defining features is the Shillong Plateau Fracture Zone, a tectonic scar brought into global focus after the 2001 Assam earthquake, magnitude 6.7. That event revealed fresh ruptures along the plateau's northern edge, particularly near the Dabbahu Fault, a structure long recognized as the southern boundary of the plateau. From above, the Dabbahu Fault stands out clearly. Running nearly 300 kilometers, it forms a dark, ruler straight line that separates Meghalaya's rolling hills from the fertile plains of Bangladesh. The fault creates a striking escarpment, with sudden slope breaks, parallel ridges, and an abrupt elevation drop visible even in satellite imagery. This scar tells a violent story. In 1897, a colossal magnitude 8.0 earthquake tore through the region, reshaping the land and leaving scarps, tilted strata, folded ridges, and displaced river channels that remain etched into the terrain today. Modern satellite imaging, from Google Earth to Sentinel-1 radar, still reveals its sharp outlines, particularly near Terapuni and Dorky. Though softened in places by erosion and vegetation, the fracture remains one of India's clearest geological wounds, a visible reminder that the Shillong Plateau is a landscape still in motion. Lake Tanganyika Rift Fault, Tanzania. Stretching across the heart of Central Africa, Lake Tanganyika is far more than a vast body of water. It is the surface expression of one of Earth's greatest tectonic wounds. This immense lake occupies the Tanganyika Rift, a dramatic segment of the western branch of the East African Rift System. What appears as a serene stretch of water is, in truth, the product of deep crustal forces tearing the land apart. The scale is almost beyond comprehension. Tanganyika is the world's second deepest lake, plunging more than 1,500 meters and extends for over 650 kilometers in length. From orbit, satellite images capture it as a razor-straight scar slicing through the continent. The rift formed as the Nubian and Somalian plates slowly drift away from each other, stretching the crust and creating towering escarpments that rise more than a kilometer above the lake's surface. From space, those escarpments appear as stark walls flanking a long, narrow valley, perfectly tracing the geometry of the fault lines beneath. Earthquake records confirm that the rift is still alive, with tremors frequently rattling its depths, while GPS measurements show the opposite shores creeping farther apart with time. In certain satellite views, shadows along the cliffs and sediment plumes reveal smaller parallel fractures, giving the rift the haunting look of a wound carved deep into the earth. Lake Tanganyika remains one of the clearest, most awe-inspiring reminders of how continents split and reshape before our eyes. The East Rift Zone, Big Island, Hawaii. Stretching across Hawaii's Big Island is one of the most dramatic volcanic scars on Earth, the East Rift Zone. From the summit of Kilauea volcano down to the island's coast, this immense fracture system marks where the volcano itself is slowly tearing apart. The rift is caused by the seaward sliding of Kilauea's massive flank, creating valleys, tension cracks, and steep fault scarps that are unmistakable from above. To satellites, the zone appears as a long, dark ribbon slicing through the landscape, its broken terrain lined with fissure vents, collapsed lava tubes, and twisted lava channels. This rift is also alive. During the 2018 Lower Puna eruption, dozens of fissures ripped open neighborhoods and forests, spewing fountains of lava that carved fiery rivers into the sea. From space, the eruption was impossible to miss, an evolving scar of molten rock stretching across the island. Even today, the zone shifts and deforms as magma pushes its way underground. Satellite missions like Sentinel-2, Landsat, and MODIS capture this constant movement, showing the rift widening and reshaping the land in real time. Unlike the great continental rifts of Africa or Asia, Hawaii's East Rift Zone is volcanic, but it works the same way. The crust is being pulled apart. Its restless nature, combined with Hawaii's stark volcanic landscape, makes it one of the most striking and easily recognizable earth cracks visible from space. The Baikal Rift Zone, Siberia, Russia. Hidden in the vastness of southern Siberia lies one of Earth's most extraordinary geological features, the Baikal Rift Zone. At its center is Lake Baikal, the world's oldest and deepest freshwater lake, plunging nearly 1,700 meters. This immense depression was formed by tectonic extension, where the Amurian plate drifts slowly away from the Eurasian plate, gradually tearing Siberia apart. From space, the rift is unmistakable, a linear scar stretching more than 2,000 kilometers across the landscape. Flanking its edges, the Baikal and Primorsky mountain ranges rise like walls, framing the narrow valley that holds the lake. In winter, when snow blankets the peaks and ice spreads across Baikal, satellite images reveal the fracture in striking contrast, a frozen portrait of Earth's shifting crust. The rift is carved by major faults such as the Sama, Morskaya, and Barguzin, which slice through forests and valleys in ruler straight lines. These scars are so distinct that they can be traced from orbit. But the Baikal Rift is not frozen in time, it's still opening. GPS data shows the crust pulling apart by 4 to 5 millimeters each year, accompanied by frequent earthquakes. Over time, these forces deepen Baikal and extend its valleys, making the region a vivid example of a continent in the act of breaking apart.